Assalamualaikum guys, my name is Farhan.
I am Ilyas.
So Ilyas, where are we right now?
We are here in Tasik Section 7 Shah Alam.
So what are we doing here?
So basically we are conducting a research about Tasik Section 7 using Newton forward divided difference. So without further ado, let's get started. First, let's begin with a brief introduction. Interpolation is a numerical technique used to estimate unknown values that lie between known data points. In numerical analysis, there are many interpolation methods such as Newton forward and backward interpolation and divided difference methods. These techniques are especially important when exact analytical solutions are not available or are difficult to apply to real-world problems. Numerical analysis itself can be seen as both a science which focuses on mathematical procedures and an art which involves choosing the most suitable method based on judgment and experience. Next, I will briefly discuss about the literature review. Our research focuses on Tasik Section 7, a man-made retention lake in Shah Alam, Selangor that functions as both a recreational area and a flood mitigation system. Accurately estimating its surface area is important for environmental management and urban planning. However, due to the lake's irregular and uneven boundary, traditional Euclidean geometry is not suitable. Therefore, numerical methods are required to approximate the area using discrete spatial data obtained from satellite imagery. For this study, we applied Newton's forward divided difference interpolation. This method constructs a polynomial that passes exactly through a set of equally spaced data points. Unlike least square methods, which only provide a best fit curve, Newton's interpolation ensures that every measured coordinate lies on the curve. To manage the lake's complex shape, the boundary was divided into 6 segments, 3 upper and 3 lower sections, and a separate interpolating polynomial was created for each segment. These piecewise polynomials were then integrated to estimate the total surface area of the lake. However, numerical modeling always involves errors. In our analysis, we considered absolute error, relative error, and truncation error. These errors arise due to factors such as limited data points, polynomial approximation of a complex natural boundary, and rounding errors during calculations. To evaluate the reliability of our results, we compared the calculated area with a reference area obtained from Google Earth. Moving on to the problem statement, the problem addressed in this project is how to accurately model and calculate the surface area of Tasik Section 7 using only a finite set of manually extracted spatial coordinates. This involves constructing interpolating polynomials that represent the lake boundary and integrating them to obtain the enclosed area. The reliability of this numerical approach is then evaluated by comparing the calculated area with a reference value obtained from a Google Earth. Next, the objectives of our study. The objectives are, first, to determine interpolating polynomials that represent the boundary of Tasik Section 7 using Newton's forward divided difference method. And the second one is to calculate the lake surface area using numerical integration. And third, to evaluate the accuracy of the numerical model by analyzing the relative error compared to the reference area.
Assalamualaikum warahmatullahi wabarakatuh. My name is Farhan. Now I will talk about methodology. First, we go to the data preparation. The coordinate of x, y, which were gathered at an inverse space interval that is h along the x-axis, are used to divide the image of the Taman Tasik Section 7 into the 6 parts. So, they give us a set of coordination ranging from the SIYI to SNYN for each section of the lake. Next, we go to the Newton forward divide difference interpolation. We use the Newton forward divide difference formulation to create a polynomial that passes through our collection point. So, we can calculate divide difference into the first, second, and third order to build a divide difference table. This transforms our condition law into a statistical function representing the lake age. Now, we go to the error calculation using definite integration. Once we had the polynomial function for each section, we apply definite integration between boundaries A and B to find the area under the curve. To ensure we only calculate the water surface, we subtract the inner boundaries from the outer boundaries. Finally, we go to the error analysis. Absolute error, relative error, and percentage error are computed using the following formula to assess the numerical approximation accuracy. Now, we go to implementation. For the first step, for data preparation, we need to sketch and divide it into the 6 sections. After that, we make a table to insert each point into each section. Now we go to the second step, that is using the divided difference. Let's look at the section 1 table. We took 4 coordinates and generate a third order divided difference table. For the third step, we'll be using the Newton forward divided difference interpolation. We only using the value of 4, 21.1. 27.1538 and negative 27.3879. We divide the quadratic polynomial exactly at the picture below. Now we go to the fourth step, that is using the definite integration. We will integrating this over using the interval of 2.25 and 4.75 give us an area of 55.4882 unit per square for the first section. For the other section, we'll be using the interval of start and end of x coordinate of each section. For the fifth step, we will be using total up all the area of each section. We will combine all the sections, so we will get a total of area of 57.0021 unit per square. For the sixth step is to find the approximate and exact value. To find the approximate and value, we need to convert it into the meter. So we will apply the scalar of 50 multiplied by 50. So our approximate value will be 142,505.25 meter per square. And for the present value, we will be using Morse counting method as a baseline. The area was estimated at 102,500 per square. Now we go to the last step, that is using the absolute error, relative error, and percentage error. To access our work, we calculate the error between our numerator approximation and the box counting method. For the absolute error, we will get 40,005.25, and for relative error, we will get 0.2807. Let's say for the percentage error, we will get 28.07%. Now we will be going to the result and discussion. You can see that this is a table of all points of each section. Next, you can look the use of the Newton divided different method. A unique quadratic polynomial was derived for each of the six sections. After that, you can also see the integration of each polynomial within its x-coordinate boundaries provide the area of that specific segment. Now, we conclude that using the Newton divided different method for the polynomial interpolation and integration enable us to approximate the area of the lead feature with measurable accuracy. The result presented in the calculated table illustrate the effectiveness of the second degree polynomial in modeling the irregular boundary of each section. We can conclude that the final percentage error is 28.07%.
Finally, the conclusion. The study demonstrates that Newton's forward divided difference interpolation can successfully convert irregular real-world geometry into a computable numerical model. However, the estimated surface area showed a significant relative error of 28.07%, highlighting the limitations due to manual digitization, data density, and polynomial behavior between points. As a result, the method is suitable for educational purposes than for high-precision geographic measurements without further refinement. So that's all from us. Thank you so much.